Hi, my name is FindKc from SingaporeStudent.com. Today is 19th of April 2012. Yesterday, we learned how to calculate Kp of certain reaction and given a certain amount of information. Today, we are going to do a very similar question, but this time the question asks you to calculate Kc of the reaction. So it's same reaction and same information. I can read the question again for you. Methanol is produced from carbon monoxide and hydrogen gas according to the following reaction: CO plus 2H2, equilibrium sign CH3OH, which is methanol. 19 mole of carbon monoxide was added to 78 mole of H2. When equilibrium is reached at 400 degrees Celsius, the mixture contains 14 mole of methanol and the total pressure is 6.9 megapascal. So up until here, the question is the same as yesterday's question. The last part is the question asks you to calculate the equilibrium constant Kc of this reaction. So again, we do a similar way to calculate Kc. This time they ask to calculate Kc. First of all, we make a pattern, the ice table for the reaction, right? There are three substances involved. The reactants are carbon monoxide and hydrogen. The product is CH3OH. And as I mentioned, if the reactant and product involve gas, so it's easier for us to calculate, to add one more column, which is the total of all these substances. Another thing is we make also a pattern for Kc for this reaction. Later we are going to apply the formula for Kc for this reaction. And since it involves volume, and volume is not given, we might need to use the formula Pp equals to nRT, also known as ideal gas formula. So we start by putting information from the question into the ice table and Kc formula. So what to do? First of all, we have 19 mole of carbon monoxide. So this 19, if you read the question carefully, this 19 mole of CO is at the initial stage. So we just put 19 there. Similarly, 78 mole of H2 also at the initial stage. So we put 78. How about 400 degrees Celsius? Do we need this? I think so. We are going to apply this number in the ideal gas formula. So we just use 400. Don't forget the temperature in ideal gas formula must be in Kelvin. So you must have 273. Other information is 14 mole of methanol, which is CH3OH. And if you read it, the mixture contains 14 mole of methanol when the equilibrium is reached. So we put it at equilibrium low. Put it here, 14. And the total pressure is 6.9 megapascal. So 6.9 megapascal, we put it also in the ideal gas formula. And don't forget to convert this megapascal into Pascal, because we must use SI units, so you must multiply by 10 power 6 Pascal. Calculate the equilibrium constant Kc of this reaction. So we need to slowly process the information one by one. The easiest way to start is by filling up the ice table, right? So the information given is in blue color, so I'm using green marker to do the working. Initially, you don't have CH3OH, you don't have ethanol, so you put 0 there. In the equilibrium, you have 14 mole of CH3OH, so is changed by 14 moles, increased by 14 moles. And don't forget, we must use the mole ratio to calculate the change in the mole of carbon monoxide and hydrogen gas. So, and the mole ratio that we use is from the equation, so 1 to 1. So you're going to put negative 28 here and negative 14. Don't forget to put the negative sign. It's because both carbon monoxide and hydrogen gas are reactant. So you must put minus in front of the number. And you can calculate the equilibrium mole. I think this is same as yesterday. So you have 5 mole here and 50 mole there. Then you can calculate the total number of mole at equilibrium. So it will be 69 mole. Why do we need this number? We need this number to be put into ideal gas formula. So 69 mole here. Other information we have are the constant for ideal gas formula we know already is 8.31. So we can calculate the volume. You can calculate the volume here. Very easy. If you make volume as a subject, it will be nRT over P. So very simple. 69 times 8.31 times, or don't forget to put this into bracket, 400 plus 273, and you divide by another bracket, 6.9 times 10 power 6. The number that you get is 0.0559. If you're using the formula for ideal gas, the unit will be meter cube. So you must convert it into dm cube. So P is 55.9 dm cube. And we need this number to calculate for Kc. To calculate Kc. So how to calculate the concentration? Very simple. Just divide by the number, by the volume. Mole divided by volume. So the concentration here is 5 over 55.9. 50 over 55.9. 14 over 55.9. And we are going to put all the numbers here in the formula for Kc. CSVOH, you're going to put it here. H2, put it here. And carbon monoxide, put it here. So 14/55.9. No, 5/55.9 and 50/55.9. Don't forget to put in the power. So a lot of students make mistake of not putting the power here. This is power 1, and power 2. And we can simply calculate. So 14/55.9 times 55.9 over 5 times 55.9 squared over 50 squared. What you get is 3.50. The unit, very simple. You have mole per dm cube, mole per dm cube. Mole square dm minus 6.